Hi guys, Dr. B here. This is a lecture about solution stoichiometry. I'm not sponsored by Mario or Nintendo or anything like that. So when we're looking at stoichiometry, you have to remember you're dealing with balanced equations, your coefficients lead to your multiple ratio, we've done molar mass, etc., sig fig rules, units and all that, metric conversions. So just make sure that you think about those things whenever you see a stoichiometry problem. And now we're going to have to include molarity, because molarity, remember, is going to be moles per liter. So you're going to see some examples where you're going to implement the moles per liter. So if you're converting mass, so grams of A to liters of B, so whatever your given is, grams of A over 1, you're going to convert over to liters of B eventually. So in 1 mole of A, you have the molar mass in grams of A, and then you're going to convert over from moles of A using your mole to mole ratio to moles of B. And then from there, the only way you're going to be able to get to liters of B is by incorporating your molarity. So hypothetically, let's say it is a molar solution of 0.2 molar B, just for this example. So that means that if molarity is moles per liter, you have to remember that if I were to rewrite this example, it would be 0.2 moles of B over 1 liter of B. So then I'm going to incorporate this fraction into here. So then it will be moles of B on the bottom, and whatever my molarity is, that number, hypothetically, say 0.2, will go there on the bottom. If you're converting from volume of A to volume of B, so you're going to have liters of A to liters of B. This will be your given, and your unknown is another volume. So you're going to be given 2 molarities to work with. And so the setup, I'll run through the setup, and then when we go over the specific examples, you can see it there. So your molarity over 1 liter of A, this comes from my concentration or my large M. The next will be your mole to mole ratio when you're converting out of moles of A to moles of B. And then here will be your second molarity, will be moles of B under 1 liter of B. This last one here, volume of A to moles of B, technically you only need 3 fractions, or 3 setup of 3. So let's say it's some given liters of A over 1, and I want to get 2 moles of B in the end. So obviously you're going to have to use your mole to mole ratio, but we've got to figure out when that'll be the case. So if you have a volume, you're going to be given another molarity in your problem. So it's your molarity in moles of A over 1 liter of A. Then now that you're moles of A, then you can convert over to moles of B with your mole to mole ratio, which comes from your balanced equation. How many liters of 0.500 molar sulfuric acid are needed to completely react with 12.0 grams of sodium hydroxide? So grams to liters in the solution stoichiometry is a total of 4 steps. So 12.0 grams of NaOH over 1, and I want to get to liters of H2SO4. But before I can even do that, I need to balance my equation or reaction. So 2 here, 1, and then 1. So 1 mole of NaOH, and on the bottom will be the molar mass of NaOH, 39.998 grams of NaOH. So So now I can convert over to moles of NaOH with this multiple ratio, with this molar mass fraction, I apologize. Then now you can convert to moles of H2SO4 by using your coefficients from your balanced reaction. So 1 mole on the top, 2 moles of NaOH on the bottom. So here, the trick with this new stuff now is that if you see a molarity like this, 0.500 moles, molar, equals 0.500 moles over 1 liter. And because it's a conversion factor, you can flip it, so you're going to put 0.500 moles of H2SO4 on the bottom, and then 1 liter of H2SO4 on the top. And you're going to multiply. 12 is my numerator. My denominator will be 39.998 times 2 times 0.5, which is equal to 39.998. I will divide these two, and I will end up with my liters of H2SO4, but you need to take into consideration your sig fig. So 0.30015, 3 sig figs, becomes 0.300 liters of H2SO4. What volume of 0.250 molar HCl is necessary to consume just the solute in 0.150 liters of 0.100 molar lead-2 nitrate? So volume to volume, it is also 4 steps. Let's see, 2 here for my coefficient, 2 here, 1 and 1. So this volume right here, this is related to my last fraction because I'm given these two. This is my unknown. So 0.150 liters of lead-2 nitrate over 1, 0.100 moles of lead-2 nitrate over 1 liter of lead-2 nitrate. Let's see, 1 mole of lead-2 nitrate for my mole-to-mole ratio. Then on the top will be 2 moles of HCl, 1 liter of HCl on the top, 0.250 moles of HCl on the bottom. So 0.15 times 0.1 times 2 is 0.03. My denominator is 0.250. I will divide these two, and I'll end up with 0.12. However, with 3 sig figs, you're just going to add a 0 at the end to make it still be the same number, it just has more sig figs. Then don't forget your units of liters, HCl, and then box your answer. How many liters of 1.2 molar HCl is needed to dissolve 5.8 grams of aluminum hydroxide? So grams to liters again, it is going to be a total of 4 steps. Okay. So balance really quick. 3, 3, 1, and 1. So 5.8 grams of AlOH3 on the bottom over 1. 1 mole of AlOH3, and then 78.004 grams of AlOH3. 1 mole of aluminum hydroxide on the bottom of my multiple ratio is the same as 3 moles of HCl according to this. Let's see, 1 liter of HCl on the top. On the bottom is going to be my 1.2 moles of HCl. 5.8 times 3, 17.4, 78.004 times 1.2 on the bottom. Let's see, 93.6048. It's going to be 0.18588, 2 sig figs, 0.19 liters of HCl. Oops. How many moles of CO2 will form if 300 milliliters of 0.500 molar HCl are added to this reaction. So volume to moles is three steps, but you need to make sure that you have your volumes in liters for it to cancel out with the molarity. So that's going to be 0.300 liters of HCl over 1. But make sure you also balance your reaction first. So I have two H's here, one here, so I'll put a 2 here. I have two Cl, so I'll put a 2 here, and 1, 1, 1. So let's see, 1 liter of HCl on the bottom, 0.50 moles of HCl on the top, then 2 moles of HCl on the bottom, and then 1 mole of CO2 on the top. 2 moles here, 0.3 times 0.5, is 1.5, oh, 0.15, I'm sorry, divided by 2 is 0.075. 3 sig figs, so it becomes 0.0750 moles of CO2. My bad. Moles of CO2. 45 mLs of 1.5 molar AgNO3 solution is added to KCl. How many grams of AgCl can be formed? So volume to grams is 4 steps, but remember that your volume needs to be in liters. So 0.045 L AgNO3 over 1. Looking at my coefficients, they're going to be 1, 1, 1, 1. 1.5 moles of AgNO3, and on the bottom 1 liter of AgNO3. Let's see, 1 mole of AgNO3. I want to convert to grams of AgCl, so on the top will be 1 mole of AgCl. So 1 mole of AgCl on the bottom, then my molar mass of AgCl on the top. So 107.87 plus 35.45 is 143.32. Luckily for us, our denominator is going to be 1, so let's double check our numerator, see what it's going to be. I multiply across, I end up with 9.6741. Okay, good. Equals 9.6741. 2 sig figs, so it becomes 9.7 grams of AgCl. How many grams of solid calcium hydroxide are required to react with 350 mLs of 0.40 molar HCl? So if you want to, you can probably pause the video, try to see if you can solve the problem, so you can make sure you understand it, and then double check your answer in your work in the end. Okay, so let's balance. I have 4 H's, so 2, 1, and 1. Okay. Three, 0.35 liters HCl over 1, 0.40 moles of HCl, 1 liter of HCl for my molarity, 2 moles of HCl. Then on the top will be 1 mole of CaOH2. I'm converting 2 grams of calcium hydroxide, so 1 mole needs to be on the bottom. And then my molar mass will be 74.096 grams of CaOH2. Kind of ran out of space. My denominator is 2. My 0.35 times 0.4 times 74.096. It's going to be 10.37344. Divide that by 2 in the calculator. I end up getting 5.18672. Taking into consideration, sig figs, 2 sig figs, so it becomes 5.2 grams of CHO2. Okay? Alright guys, if you have any questions, please let me know. Hit that like and subscribe and all that, blah blah. Thanks, bye.